Okay. So, ladies and gentlemen, okay, it says find whatever this means in terms of, it's a continuation on of the previous day's notes, in terms of x and y, okay? So, guys, this is the notation for a second derivative, okay? That is the notation for a second derivative. So what's going to happen is we're going to find the first derivative, and then we're going to find a second derivative, but it's going to look a little bit different because I'm not dealing with a function. I'm dealing with some sort of equation that doesn't satisfy the function definition. Okay? So x squared plus y squared equals 25. Looking at this, if we just even remember conic sections or geometry for that fact, what is this? A circle with a radius of 5. Yeah, exactly. So, first thing we're going to do is we're going to go through and we are going to find the first derivative just like we did yesterday. Okay? This one's nice and easy. The derivative of x squared is going to be 2x. The derivative of y squared is going to be dy dx. You got it. I know, you can't forget that because if you do, it'll mess you up. Now, we're going to go through, we're going to solve this for dy dx. So that means I'm going to subtract 2x from both sides. 2y dy dx is equal to negative 2x. All my dy's are on one side. Everything without that is on the other side. I'm going to go through and divide. So therefore, dy dx is equal to negative 2x over 2y. Can I make this any simpler, or should I just leave it? Yeah, let's factor out that 2, right? And let's cancel it. So, in other words, dy dx is really equal to negative x over negative y. And if you actually graph this, you would see that it's true. Everywhere you're going to have a slope of like if you use the 0.55, it's going to have a slope of negative 1. That kind of makes sense if you think about a circle, right? So right here at the point, whatever that is right there, if the x and y values are the same, right? So here it has a slope of negative 1. If my point was here, it would be undefined because I'd be dividing by 0. If it was here, my slope would be 0. Okay? This is in fact true. Does that make sense to you guys? Do you see what I'm doing there? Okay. So, what we're going to do now is we're going to take this first derivative and now find the second derivative. Okay? So, when I take a second derivative of dy dx, that's how it turns into that special notation, that d squared y all over dx squared. Okay? So, d squared y all over dx squared. Now, I haven't done anything here, but just looking at this, I have negative x over y. What rule should we apply? Let's use quotient rule, right? So here, I'm going to take the derivative, and let's just have the negative go with x. What's the derivative of negative x? Negative 1 times y. Minus, what's the derivative of y? 1 dy dx times negative x, right? And that's all over, and some of us are even forgetting this when we use quotient rule, all over the derivative squared. Now guys, as we look at this, this is kind of ugly in terms of what makes this ugly. dy dx, right? But you know what dy dx is. What is it? So, I know what dy dx is. I'm going to take this and I'm going to substitute it here. Okay? So, d squared y all over dx squared is going to be equal to negative y minus 1 times negative x times, I'm going to substitute dy dx with that negative x all over y squared. Okay? And then as I look at this, I can still go ahead and clean this up a little bit more, guys. In fact, let's just focus in on our numerator right here. So maybe I'm going to do some side work over off to the side. Like, okay, I'm going to try and figure out how I can rewrite this numerator. So negative y, I'm going to change it to a plus x times negative x over y. So far, are we okay?
Yes.
You understand what I did there? Okay. So if I look at this, I have this term and this term. I should probably get a common denominator, because if you look at this, that's what it is, right? So what could I create my common denominator of? Y. So this first fraction needs to be multiplied by y over y. This,
Negative y squared.
it will be.
Minus x squared over y.
And this one will just be 1 over 1, right? So I have negative y squared minus x squared all over y. Okay. So this is now becoming my numerator. You guys cool with that? So negative y squared minus x squared all over y. And don't forget, you still have that denominator of y squared. But some of us get confused, and you're all like, I don't know what to do with this, but what can I make this? You can make it, yeah, you can make it a fraction and multiply by its reciprocal. So 1 over y squared, that's what this is going to turn into. So therefore, your second derivative with respect to x is going to be negative y squared minus x squared all over y to the third. You could. In fact, you could simplify this so much. What could you take out here?
Y. Negative 1.
You could take out a negative 1, which would leave you with y squared plus x squared all over y cubed. And there's one other item we could actually do. Brendan, let people think, unless you don't know what it is. Guys, you know that y squared plus x squared is 25. Okay? So here, the second derivative, did you know what it was or no? This is the most simplified version of that second derivative. Okay? So guys, when you go to the homework and you start looking for that answer, you might have this, and for some reason I have this. It's because I've used something in the previous equation to help me get there.
Would you